In this video, we're going to write the equation of a quadratic function given intercepts on a graph. So let's write down what our intercepts are. We have our x-intercepts, which are negative, this would be 1, 0, and 4, 0. And these are called zeros for the quadratic, so these are also known as zeros. Or we could call them the solutions. And then we have the y-intercept, which is 0, -8. So we have these three coordinates that we've pulled from this graph. How do we write an equation? And they want it in general form. How do we write the equation for this parabola? Well, the x-intercepts actually tell us our solution. So if we kind of work backwards, we would say that we have x is equal to 1 and x is equal to 4. So we're going to kind of work backwards, like we ended up with these as our solutions. How did we get there? Well, we would have at some point done the zero product property. So if we go backwards a little bit, we'd have x minus 1 equals 0 and x minus 4 equals 0, because those are the two solutions, so we're working back to its factors. Well, this would have came from doing a ZPP, which means that this was really x minus 1 times x minus 4 in our equation. Well, we don't know the leading coefficient, so I'm going to say that the leading coefficient there was a, and that this would have said f of x is equal to a x minus 1, x minus 4. So we're just kind of working backwards there. So basically, the short story there is that if you have the two x-intercepts, you can immediately write the two factors for your quadratic by just saying that this is the solution, this is the solution, so the factor would be the opposite side, x minus 1 and x minus 4. So you can kind of skip this whole working backwards, but this is the thought process to get to this piece. Well, now that we have part of our equation written, we can go back to our y-intercept and we can use it to find a, because we need to find a to have the equation. So we can take -8, put it in for y, so we have -8 is equal to a 0 minus 1 for x, 0 minus 4 for this other piece. So we end up with -8 is equal to so -8 we just lost power for a second, so just gotta finish this video. All right, we're back. Sorry about that. So we got -8 is equal to a 0 minus 1 times 0 minus 4, so you'd end up with 4a. We'll divide by 4 on each side, and we get -2 is equal to a. So then we can plug that into our equation, and we get -2, x minus 1, x minus 4. We can go ahead and distribute all that to get this into general form. So we get -2 times x squared, when we do x times x, minus 1x, -1 times x, minus 4x, plus 4. So I end up with -2 x squared minus 5x plus 4. And then I can distribute the -2 to each piece. So I get -2 x squared plus 10x minus 8. All right, let's do a second example here. in the second example, we can write down what our intercepts are right away. So we can say the x-intercepts are -2, 0, and 1, 0. The y-intercept is 0, -2. Now, we can go ahead and write that our equation is f of x equals a. I have my two factors here. This would be x plus 2, remember opposite sign, and then x minus 1. And then I can take my y-intercept, plug it in, so I get -2 equals a, 0 plus 2, 0 minus 1, minus 1. So I plug those in, and that would be 2 times -1, which would be -2. So I get -2 equals -2a. Divide by -2 on each side, and we get 1 is equal to a. Let's take this, plug it back in. So we have f of x equals 1, x plus 2, x minus 1. Now obviously the 1 doesn't need to be there, so we can just distribute it in here, and we get x squared plus 2x minus 1x minus 2, which gives us f of x is equal to x squared plus 1x minus 2. So that's how you use your x-intercepts and your y-intercepts to write the general form for a quadratic.